moderator for today. Yes, so today we are here to discuss on a very important topic. That's key consideration in sizing the lithium batteries, that's the LiFePO4 batteries for solar PV system. So the essence of this topic is to get the basic knowledge in order to. Hello, are you with me? Please, can you just mute your phone? No, no, no. Okay, good morning, everyone, and welcome to today's webinar. My name is Morenike John Motosho, and I'll be your moderator for today. So today we are here to discuss on the topic key considerations and sizing the LiFePO4 batteries for solar PV systems. And we are fortunate to have our speaker, Engineer Kule Olorunkoya, who will be sharing his expertise on this topic. So please feel free to ask your questions throughout the session via the chat box, and we'll address them at the end of this topic. So without further ado, let's welcome Engineer Kule to kick off the session. Thank you.
Good morning, everybody. You are all welcome once again. Going straight to the topic, why lithium ion? Why lithium batteries for solar? We have um, the points highlighted. The higher, they have higher efficiency. They last. They have longer lifespan. They have fast charging capability. That you can really fast charge them. They are not the range of how fast you can charge them is wide compared to other batteries that the manufacturer will tell you maybe 5 amps or 10 amps for 20 hours. Or you can actually charge this battery within 3 hours is full. So you have a low self-discharge rate, which means when it's kept fully charged, when it's not in use, it doesn't rapidly self-discharge compared to the other batteries. Deep discharge rate, that means you can take heavy current from it without harming it. You know, other batteries is what you use to charge it is what you are allowed to take from it. If you take heavier current from such battery, you'll be reducing the capacity. It's not that it's not the same in lithium ion battery. You can actually charge it with, for instance, now if it is 200 amp hour battery, or which is maybe 48 volts, and that's about 10 kilowatt hour. Under normal condition, you are supposed to just charge it maybe with 20 amps or 10 amps, depending on the manufacturer specification for. But for lithium ion battery, you can take 80 amps from it. You can give it 80 amps for it to charge. That tells you it will charge very fast. And when there is a need to for heavy startup current, is there to answer. Doesn't affect it negatively. So far, whatever you are taking from it is within its specified limit. So it has higher energy density, and that's part of what we have just discussed now. It's full of energy. Can 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 charge it fully and it will remain like that. The energy you give to it, you'll be able to take it back. Low maintenance. It doesn't require maintenance like that because um, apart from the terminal, once you lock the terminals very well and everything is in good shape under normal condition, the body maintenance is just cleaning. Then you want to check how is the performance, which you can always get from the inverter itself or display or anything. So it's not like the other batteries that you need to be monitoring each battery voltage, current, the internal resistance, and many other parameters like that. No, it gives you more rest of mind. Then smart smart battery management system. That's a circuit that has the full protections of the system. It protects it against overload, protects it against overcharge, against high temperature. So it's a smart battery that is intelligent. So all the other things, it gives you rest of mind. You don't need to be doing them yourself. Things that you are supposed to carry thermometer, go and do. The battery will do it by itself. So it's having increased system reliability. When it's in your system, you are rest assured of the performance. So that's that. Then the next is the key difference between lithium and LiFePO4 batteries. The chemistry, different chemical composition, and that is what affects the performance because the chemistry is different, so the performance too is different. For LiFePO4, lithium ion phosphate, that's the LiFePO4. It's a lithium iron phosphate, and it's having that phosphate is one of the protective ingredient against high temperature and fire. So the battery is highly protected and secured. Now, safety. LiFePO4 batteries are less prone to thermal runaway. That's talking about temperature. They don't rise in temperature so easily. Even when they are loaded, they don't rise in temperature like that. So they are less prone to thermal runaway. Then thermal stability. They operate efficiently in a broader temperature range. That means a wider temperature range. So that's what that means. That's within a certain limit that is wide in terms of temperature. It's not so narrow. For some people, they will just be giving you maybe between 25 to 25 point something, so narrow. But for like PO4, it's wide. That's why you see them. They don't have fans. Most of them don't have fans because the internal generated heat is minimal and then it's controlled and monitored. So they don't require the conditioner to say much. Then the discharge rate, the batteries have higher continuous discharge rate. Like I mentioned, you can take, if it's rated like 100 amps, I'm not saying 100 amp hour now, 100 amps, because in terms of current, it will give, the specification will dictate the parameters. And then part of the parameter is that this particular battery, you can charge it with 100 amps or 200 amps. You can discharge. That's maximum discharge or charge current. Although you are not expected to be operating at maximum capacity for anything, any equipment or any unit. But they are telling you that in case something happens and you operate at that, it's not still going to damage. It's going to shut down when you exceed that maximum. So that maximum now, look, for instance, you can operate at, if the a lithium ion battery is rated 100 amps, you can operate at 50 amps, you can operate at 60 amps, 70 amps, doesn't harm it. The only thing you notice is that the time will be shorter because it's still the same battery. The time, they are rated in hours. They are time, they are time component. So you cannot rule out time in their operation. So if you increase your load, the time will become shorter. So that's just the thing. It will only now shut down when you exceed that maximum rating, so which is wide compared to other batteries. Sizing lithium batteries for solar PV system. Now you need to first of all determine daily energy needs. It is very, very important because you want to power load. You must know the consumption of that load before you now talk of the equipment that is going to power it. So that's where you start from. You calculate the daily energy consumption for each appliance, and that is wattage times usage hour. For instance, if your load is just 10 watts, then you run that load that's 10 watts, you run it for 10 hours. That's 10 times 10. That's 100 watt hour. So sum the energy consumption of all the appliances to get the total daily energy consumption in watt hour. So it's still the same thing. It's not only one appliance you want to power. You sum up all the way they operate. For instance, if your fridge runs for just 5 hours and you know the energy for that. If your fan runs for 20 hours, you know the energy for that. You put them separate, and then sum them together to give you the total energy that is that you want to that is required, because that's what you want to power. Now, example is this. If you have a television, for instance, of about 200 watts running for 6 hours, that means the energy is 1,200 watts hour. So just multiply that 200 watt by the number of hours of operation. Repeat this for all appliances and sum the total. The next is to calculate the battery capacity. Depth of discharge, which we call DOD. Typically, a DOD of about 80% to 90% is recommended for lithium-ion batteries. And this does not really harm them, does not harm them. You can use, that's why they say it's having a deep discharge rate. So, days of autonomy, the number of, this one means that it's the number of days you want the batteries to power your loads without solar input, just the battery when it's charged. So how long can it power your load continuously without shutting down? That's what it's talking about here. Then battery capacity in watt hour equals daily energy consumption multiplied by days of autonomy, then divide by DOD. Examples, if daily energy consumption is 1.2 kilowatt hour with 2 days of autonomy and the DOD is 80%, then the battery capacity in watt hour equals 1,200 watt hour times 2, which is the number of days. Then you divide your answer by the DOD, which is 80%, now 0.8, and you get 3,000 watt hour, which is 3 kilowatt hour. That's the capacity of the battery that's going to power that load successfully based on the timing of run. Now, system voltage. Of course, you need to understand, you need to know what the system voltage is. We have different types of inverters, for instance, or charger. They have voltage they operate with. We have 12 volts inverter, we have 24 volts inverter, and we have 48 volts inverter, and we have higher voltages too, but these are the common ones. Now, the system voltage affects the amperage required. If your load is much and you want to use a 12 volts, then the current will be high. Higher voltage system reduce amperage, which reduces cabling losses and even the cost of cable, not just losses. The cost of cable at the end of the day will be reduced because you'll be using, maybe instead of using maybe 16 mm, for instance, because the voltage is high, you may end up using maybe 10 mm. It's just an example. I'm not saying you should connect 10 mm to a 12 volt system or anything, but that's sizing in terms of cable. Other key considerations. Then the charge controller sizing. The solar charge controller must be appropriately sized to deliver the charging power needed by the battery. This is very, very important. If you have a battery that the charging current, the minimum charging current, for instance, let's even say is minimum charging current, maybe that can charge for 10 hours, is 20 amps. You don't go ahead and get a charger that the maximum charging current is just 10 amps. That means it's going to stay long for maybe more than 20 hours before it's full. So it's a waste of time. When in lithium ion, you can even charge the battery within 3 hours and it's full. If you have a charge controller that has that capacity to pump the energy into it. So you consider that and consider future expansion. You don't just limit the capacity of the charge controller or to just one battery. Your client may want to increase the batteries to 4 at the end of the day. For instance, if the battery you are operating with is about is just 10 kilowatt hour, and your client is going to 4 units of that 10 kilowatt hour, you don't limit your charger to just one. Of course, look for a charger that has capacity that can handle 2, 3. Even if you cannot handle everything successfully, you may need additional, but don't just limit it at that first stage. Now, factors to consider in choosing a lithium battery. Cycle life. Usually, LiFePO4 batteries have long cycle life. You can see some of them about 15 years. So you consider, check. It's very important because this is talking about how long it's going to stay in your system as you continue to use it. So if you don't consider that, maybe the manufacturer of the particular model or the brand you have stated in their specification that it's just about 8 years, and you, because they say the lithium battery they last longer, you are thinking you use it for 20 years. Then when it starts showing you signs, you'll be worried. So be detailed, go through specifications, find out, check, ask professional, check their details, go online, find out about the batteries you want to get, and be sure get from a reputable company, a reliable source. There are different types of batteries out there, so-called lithium-ion battery. So one has to be very careful. Another point is max charge and discharge current. That's the maximum charge and discharge current. It's always high. So you need to look at that too. Because of your application, if you want to power a pump that demands for a startup current that is higher than your battery, then the battery will shut down when the load is about to start. And this is not good at all. It's not professional. So look at what they say the maximum current, so that the battery will be able to withstand the surge current demand by the load. Very important. Efficiency. Of course, all these are part of the specification. So you look at it. Is it efficient? They'll put the percentage there. Temperature range. You see the range. You can compare with others and see. Lithium-ion batteries have wider range of temperature effect. Then safety features. What are the safety features they have for that? Is it just overload? Now, these batteries are very intelligent, like I mentioned before. They have overload, they have temperature measurement, at least sensitivity control, and then they have short circuit. They have display to show you all this. So they are smart enough, and all these protective measures are there. So smart battery management, which is the BMS. So what type is it? Is it that is much reliable? There are different brands out there. Capability. What's the battery capable of doing? That is why it is important to go through the full detailed specification of the product. Brand and reputation. Please check. Like I mentioned, buy from a reliable source. And before you buy, you can check and get your details. Okay, you can see the pictures we have. These are different shapes, different capacities, different voltage levels with different features. They are all lithium ion batteries. You can see 12 volts, SVC, 200 amp hour, which is exactly like your 200 amp hour lead acid battery. But this is highly reliable. You can compare the performance of lithium ion, just like we expatiated, with the other what's it called, the lead acid batteries. So the weight, because this is one another feature, which is another part of the thing. They are light in weight compared to other batteries. They are very light. The weight is like close to half of lead acid, all those AGM. Like this one you are seeing in this black one now is 200 amp hour. The weight is just like half of the other one. I think just about 25 or thereabout. If one battery is about 50, 50 kg, this one is just about 25 to 27 or so. So, and it delivers the accurately the power, the energy required as stated in the specification. So the same thing is applicable to others. You can see the SVC rack mounted, which is a 5 kilowatt hour, 5.12 kilowatt hour, 24 volts, 200 amp hour battery. So it's 40. So you can see the other one, wall mounted, which is a 5 kilowatt hour. That's a 5.12 kilowatt hour, 24 volts as well. Then you can see that standing one, which is a 15.36 kilowatt hour, 48 volt. That's 300 amps hour battery. So under the wall mounted, we have also 10 kilowatt hour, which is 10.24 kilowatt hour, 48 volts, 200 amp hour, 200 amp hour battery. So they have different capacities. So you need to be familiar with all these capacities while you are taking your decision. It's very important. Then you can see mega tank, which is 5 kilowatt hour lithium batteries. You can see how they are cascaded. You can put one on top of the other. You can cascade them, put one on top of the other one. You can see three cascaded in the picture. And that's to make 15 kilowatt hour. Thank you.
All right, thank you. All right, thank you, everyone. Thank you, Engineer Kuli. We have actually covered a lot in a short time, and then we'll be taking some questions. We already have some questions on the chat box. Okay, we have a question from Diadem Solar, and he asked, what's the major function of the BMS? Hello, Engineer Kuli. Are you with me?
Yeah. Asking about the major function of the BMS, um, as the name implies, battery management system. So is the brain box that manages the affairs of that battery, how the rate at which it charges, what it will demand for when it wants to charge, the voltage level controlled, when is the one that takes all these sensors signals and make sure that they are all active. When the battery is required to be disconnected, maybe due to high temperature or overload or anything, is that BMS that does that. So that the battery is highly protected. If you short circuit it, instead of it getting damaged, that BMS is the one that will say, oh, the battery is there is a short circuit, let me cut it off. Oh, there's a rise in temperature, let me shut down the battery. Oh, the charger is not working well, the charger wants to overcharge this battery, let me cut off the charger. Oh, the inverter is demanding for too much current than what I can give. Let me cut it off. So is the that's why it's called management. Is the one that's managing the battery inside. So when other conditions outside wants to affect the battery's cells negatively, the BMS will not allow it. And it's still the one that gives you the display to see what's going on. So he interprets what's going on. Oh, this is the battery voltage, this is the temperature. Oh, there was an overload at some point. It will record all this. Is the memory, is the general manager of the battery cells. I think that answers your question.
All right. Thank you for that. Okay, so we have another question. Yeah, I think I will just address this. The difference between BMS and SBC, sir. Okay, so the BMS is the major component of the battery, while SBC is the brand name of the LiFePO4 battery that we saw. So I believe that answers your question. So we have another question. Can transformer-based inverter use lithium-ion battery?
Yeah, usage of lithium ion battery does not depend on whether the charger or the inverter is um, transformer based or transformerless. What matters is the function, what the way they work. So if you have an inverter is an inverter. So far, it is programmed to give out this voltage, and they've designed it to communicate with the battery. It's good to go. So far, it's intelligent enough to say, okay, this is the charging current the battery is demanding for. Let me give it out. You're able to program it, or when it's communicating, they communicate within themselves. So it has nothing to do with whether it is transformer led or transformer based. I think that's the answer to your question.
All right. Thank you. Okay. So we have a question here, and it says, "Thank you, Engineer Kunle. You have not talked about sizing solar panel for charging of LiFePO4 battery."
Okay. Solar panels, I won't say is a different thing entirely, but then because you want to get your energy from the solar panel. Um, what matters most is the capacity you want to get from the solar panels. That is the demand. Once you have you is not the solar panel first, it is your load first, and then you now put the inverter in place. Of course, when you are designing when you are choosing inverter, you choose the one that can handle the number of solar panel that is required. So for instance, you have a battery of 10 kilowatt hour, and you want to charge with solar panel. You want to determine what the solar panel will be. You know, naturally, solar panel don't give exact wattage continuously. So for instance, if you have 200-watt solar panel, you can continuously be getting 200 watt from it. But we can say, okay, 200 watts, and then you know the sun hours is just about 4 hours, 5 hours max, if you really want to be safe. So if you are choosing 4 hours, that means within 4 hours, if you really mean business and you want the system to work well, your battery should be charged. So that means you should be able to pump the required energy into the battery within 4 hours. Your solar panel capacity should be such that you'll be able to deliver the energy into the battery within 4 hours. So if you want to use 4 hours for a 10 kilowatt hour battery now, you know, that may mean that we'll be charging it with um, about 40 or 50 amps if it's 48 volts. So 50 amps, which means that 50 amps at about 50 volts, that's 2,500 watts, roughly. This is just a rough calculation, it's just a guide. Now, which means your solar panel should be able to deliver this energy. And you now know that you want to power the load during this time too. During the 4 hours, it's not just charging you want to do, which means you size for your battery charging and you size for your load. What's the capacity of the load you want to power at that time? And then you calculate for the panels that will handle the load. You add everything together. That's the number of panels that you should put on the roof. So that when the battery is charging within that 4 hours, it will be full because you have calculated for it. Then you are also powering your load at the same time. That is in case of complete off grid. Now, but if you know that you have alternative energy supply, you may not put everything on the solar, because if you put the whole demand on solar, that means you use a lot of solar panels. But if you know that you have alternative that is sure that it's not going to, solar is like free at the end of the day, because once you put it there, you have installed it, it's there. When sun generates, you don't pay sun for giving you that energy. But if you want to use your generator or public supply, it may.
All right, thank you very much, Engineer Kunle. So we have there are a whole lot of questions here, and then we'll address this question. I think I can be able to handle this from my hand. Lithium-ion batteries are prone to explosion. How does one prevent such fire accident from occurring? Now, thankfully, that is the essence of the monthly webinar that we organize from Genesis Technologies. So basically, or in general terms, lithium-ion batteries are actually not recommended for residential or commercial purposes. They are only used as your phone batteries, your laptop batteries, but not suitable for solar energy. So that is one basic factor here that we want us to acknowledge. So for your residential or for your solar installation, we highly recommend the LiFePO4 battery. That is the lithium ion battery, which we sell here at the Genesis Technologies. So available in stock for the LiFePO4 battery, we have them available in the 15 kilowatt hour, 48 volts. We have them available in the 10 kilowatt hour, 48 volts. And then we also have the Mega Tank 5 kilowatt hour, 48 volts. And then you can be rest assured that these batteries are LiFePO4 batteries, not lithium ion batteries. The lithium ion batteries have higher charging density, like Engineer Kule has explained at the beginning of this lecture, while the LiFePO4 batteries have lower um, charging density compared to the lithium ion. So because the charging rate is higher, they are prone to overheating and can explode. So which is why we always recommend the LiFePO4 battery. So I believe that answers your question, sir. So on a final note, to be addressing one more question. Um, okay, this is a feedback. Thanks for the presentation. Yeah. So from
Let
True
me just
Power
ask.
Solution, yes, we have a question from True Power. He said, please, does your 12 volt SVC lithium battery come with BMS inside?
Which one? Yeah, it came with BMS. There's none of our lithium ion batteries like PO4 that does not come with BMS. It's always there, no matter how small, because the battery has to be properly managed. Then, in addition to that, like PO4 that we are talking about, is actually having an ingredient or a component that fights against that explosion that that person was on, which is the phosphate, especially fire outbreak. It fights against it. It's a component that has been added to it during manufacturing. So that's what makes it unique to other batteries.
All right. Yeah. Thank you for that. So we have a question from Hassamad. He said, thank you, Engineer Kunle. Please, I want to ask if I use an hybrid system in a setup, I will want to increase the solar panels for charging the setup. Is it advisable to use an external charge controller as the inbuilt MPPT of the hybrid, if the hybrid is occupied? If yes, what is the best way to connect it to the batteries? Thank you.
Okay, I know this type of question definitely will come because we are always professionally against using external charge controller for batteries. But when it comes to this type of battery, like PO4, with the capacity of charge current that it can take, it is wide enough. And because it's wide enough, you can use external charge controller, provided when utility supply is available and sun is the solar energy is also available, the two together when combining on the battery will not be more than the specified maximum capacity of charging on the battery. So what I'm saying is this, for instance, for lead acid battery is just about, in the common type, like all this 200 amp hour is just about 20 amps. And you are not allowed to be charging it or discharging it with 30 amps or 40 amps. It's going to dangerously affect the battery. But for lithium ion, yes, it's 20 amps. But it is stated that you can go as high as 100 amps and it's not going to harm it. So, but we now say, okay, instead of you operating at the maximum, you can operate at about 60 amps, which is still wide, 60, 70. When you are operating at that current, your utility supply may not be able to deliver that fully. Maybe your inverter can only deliver 20 amps and the charge controller is already delivering additional 20 amps. That's 40. It's still not dangerous to the battery. So if you want to increase, you can add external charge controller. I know why you want to do that is you want to be economical instead of you buying another inverter, which may be expensive. You want to use charge controller which costs lesser than the whole inverter. Good. When you add it, it should not go and deliver the in addition to utility supply and what is already there, which we say probably they are just 40 for the two of them. While you are not bringing another one, maybe that one is just 20 or 30. You see, if it's 20, that makes it up to 60. It's still okay with your battery. So you can use it. So that's the consideration you need to put in place. Make sure that when everything comes together, because that's the worst case, what am I going to get on the battery? Once you see that it's not going to be dangerous to the battery, you can go ahead. And your charge controller must be intelligent enough that you must be able to program it that you don't overcharge the battery. Although the battery cannot easily be overcharged, but it doesn't mean that you should expose it to overcharge because it will show error and shut down, which is not good for a good design. Thank you.
Okay, so we'll be taking one final question from Kunle on the group. He said, I bought a 15 kilowatt hour SVC battery and it was written residential. What does this mean? So I'll be able to address this. What it states categorically is that the battery is suitable for both residential and commercial purposes. So I believe that answers your question. So that will be all from my end. So the general question I've been asking or I've been getting here is if they can get a recap of this presentation. Of course, we have covered a lot in a short while. And as always, we are ready to assist our clients in any way possible. For those who are unable to join and for those who joined late, this presentation will be uploaded on our YouTube channel before the end of the week. So please don't forget to like, follow, and subscribe to all our social media handles on YouTube at Genes Technologies, on Facebook at Genes Technologies, and on Instagram at Genes Technologies. So on our social media handles on a daily basis, we get to drop updates there too. So thank you for your time and have a great day. Bye.